Good morning, everyone. I am M. Venkatesh, working as an assistant professor in EEE department in PVR Viswadaya Institute of Technology and Science, Kavali. In this video, I explain the derivation of EMF equation and problem solving on EMF equation. So, what is EMF? EMF is nothing but a force which drives the electrical current in electrical circuit. So in the DC generator, they induce the dynamically induced EMF. That means it's a rotationally induced EMF. So that EMF getting from the generator. So how to derive this EMF equation? How to derive this EMF equation? Let us see here the EMF equation of a DC generator. In this EMF equation of a DC generator, so is some terms getting from the EMF equation. So what are that? What are they? So here capital N is speed of armature in RPM, that is revolution per minute. Capital P is number of poles in number of poles. Capital Z of number of conductors. Capital Z is total number of conductors. Capital A is number of parallel paths. It is depends upon the connection of type of armature winding. This is the pi symbol. So this is for flux per pole. It is units of Webers. And capital E suffix G is nothing but induced EMF or generated EMF. Okay, so the EMF is induced in the DC generator. By depends on the Faraday's laws of electromagnetic induction. So according to Faraday's law, the induced EMF is directly proportional to the rate of change of flux. That's why here I am simply write the Faraday's second law, that is E is equals to d pi by dt. So this is the basic equation from Faraday's law. So in the generators also we are getting the induced EMF from the Faraday's law, like Faraday's laws of electromagnetic induction. So here we have P number of poles and pi equals to flux per pole. So what is the total flux cut by the single conductor? That is simply taken as d pi for a single, that means a small conductor. So here I am taking as for a small revolution, that is one revolution, how much flux cut by the one conductor, that is simply taken here, that is d pi. So here we know that the total flux per pole is pi and the total number of poles is p. So the total flux per pole into poles, it gives the flux. That's why here d pi equals to pi into p. So and then the total number of revolutions per minute is capital A. So what is the revolution per second? Revolution per second is 1 minute equals to 60 seconds. That's why here n by 60. In 1 second of time, how many revolutions? In 1 second, how many revolutions? 60 by n. So in 1 second time taken for the 60 by n revolution. So that's why 1 second equals to 60 by n. So coming to in the Faraday's second law, the EMF equation is equals to d pi by dt. So here d pi is nothing but total flux and dt is nothing but time. So for one revolution, what is the total flux? Pi into p. And dt is the time taken for the 1 second. For a revolution, one revolution, what is the time? So 1 second. In 1 second, how many revolutions? 60 by n. So that's why, so pi p by 60 by n. That is taken as 60. Simply pi p n by 60. Pi p n by 60. Or the flux cut by each conductor per second is flux cut by one conductor per revolution into number of revolutions per second. So here the revolutions and revolutions are going to be cancelled. Then we are getting the flux per second. This is simply equal to Faraday's second law, that is E is equals to d pi by dt. So here we are getting the equation pi p n by 60. this pi Pn by 60 is taken as a average EMF of a generator, average EMF of a conductor or generator. So this average EMF is multiple with total number of conductors and number of parallel paths. So here the total number of conductors is capital Z and the number of parallel paths is capital A. So that's why the total induced EMF is write as EZ equals to pi Pn by 60 into Z by A. So here the red color indicates the EMF equation, total EMF equation of a DC generator. Okay, so in this A is depends on the armature winding. If A equals to P for lap winding, if A equals to 2 for wave winding. Okay, so in this EMF equation, from the EMF equation, the induced EMF is directly proportional to the flux and directly proportional to the N. So if flux changes, induced EMF changes. If speed changes, induced EMF changes. Okay, so this is the EMF equation. So how to solve the problems on EMF equation? Okay, so let us see. We have some problems in our slide. Okay, so here we have the three problems. That is our first one, second one, third one. So these problems are explained here in this slide. So here, so first problem, I am taking the problem number 1. So a 8-pole DC generator has a pole flux of 40 milliwebers and winding is connected in lap with 960 conductors. With 960 conductors, calculate the generated EMF on open circuit when it turns at 400 RPM. When it runs 400 RPM. If the armature is wave wound, at what speed must the machine be driven to generate the same voltage? So you can see here. So in here it is 8-pole machine. So it is 8-pole DC generator and the flux. So flux per pole is what? 40 milliweber and winding is connected to what? Lap winding with 960 conductors. That means what? Here the Z. So 8-pole. Pole equals to 8-pole. That is a 8. P equals to 8. Flux per pole. What is that? 40 milliwebers. And then so it is a lap winding. That's why number of parallel paths equals to 8. And here we have the Z. That is the number of conductors is Z. That is a 960. And what is the speed? 400 RPM. So at that time calculate the generated EMF. It is the case 1. Okay, so see here in the case 1. So I am using the EMF equation by EG equals to pi Z NP by 60 into A. So I am simply place the values, what values given in the problem, that is the values here, and then I am getting the 256. So 40 milliwebers into Z 960 into N 400 RPM into P 8 by 60 into A equals to number of parallel paths, that is a lap winding, that's why A equals to P. Okay, so coming to next, we have a if the armature is wave wound, at what speed must the machine be driven to generate the same voltage? You can observe, to generate the same voltage. What is the generated voltage? So that is the induced EMF is same voltage. What we are induced in previous 256. That's why here I am taking easy as 256 volts, and it is our armature is wave wound. That's why A equals to 2. A equals to 2, and find the speed. Find the speed. So that's why from the EMF equation I write the speed equation N equals to EG into 60A by pi ZP. That is simply substitute the values. I am getting the 100 RPM here. Okay, this is the first. Okay, so this is the first problem. So here we are simply calculate the EMF from the given formula, from the formula, and simply substitute the values. And if change the wave winding, then what happened in the speed? Okay, so you observe here initially it is a 400 RPM, but when it is going to be wave winding at the same voltage, again it is reduce the speed, that is a 100 RPM. Okay, going to see in the next problem. So the armature of Second problem number 2. The armature of 6-pole generator. That means what is the number of poles? 6-pole generator has wave winding containing 664 conductors. Calculate the generated EMF when the flux per pole is 60 milliwebers. The flux per pole is 60 milliwebers. Flux per pole is 60 milliwebers. And then what is the speed? And the speed is 250 rpm. So find the speed at which the armature must be driven to the generator, and the EMF is going to be, and the EMF is 550 volts if the flux per pole is reduced. If the flux per pole is reduced to 58 milliamperes. So here you can see the first one. Here, 6-pole generator has a wave winding, containing 664 conductors, and calculate the generated EMF when flux per pole is what? 60 milliwebers, and speed is what? 250 rpm. Speed is what? 250 rpm. So find, that is the first case. So in the first, calculate the generated EMF. So in the case 1, so in the case 1 I am simply what? So see here the case 1. So then what happened? So here I am writing simply the given data. So what is the 6-pole? P is the 6-pole, and A is the armature winding 2. So wave winding, and Z is the number of conductors 664, pi equals 60 milliwebers, and speed N equals 250 rpm. So then I am simply substitute the values. So actual formula. This is what? E pi Z and P by 60 into A. I am simply substitute the formula here. Then I am getting the value of what? 498 volts. So coming to in the case 2, in the problem remaining is find the speed at which the armature must be driven to generate the EMF. What is the generated EMF here? 550 volts. If the flux per pole is reduced to what? 58 webers. So what means? So generated induced EMF, that means EZ equals to 550 volts, and then it is reduced to 58 milliwebers. Then what is the speed of the machine at the same machine? So that's why I'm simply take the formula from the EMF equation. N equals to Eg into 60A by pi into pi z p. So here EZ equals to 550, 60 into A equals to wave winding. That's why 2. Pi is going to be reduced 58 milliwebers, and Z equals to 664 conductors, P equals to 6. So then what happened? We are getting the 285.6 rpm. So here you can observe. It is a wave machine. So wave winding. So in the both cases you observe that wave winding. So but here the flux is going to be what? Reduced. So initially you have observed here the flux is reduced and speed is what? Increases. So speed is going to be increases. Speed is increases. Okay. So here, so you can see the EMF problem. Okay. So this is the one. So in this problem, what we observe from this problem? So we observe only when the speed is going to be increases, if the flux is reduces, very small factor. Initially it is a 60 milliwebers, and secondary the flux is going to be reduces 58 milliwebers. But if speed increases to 50 rpm initial, that is the first case. So in the second case we are at 285 rpm, 285.6 rpm. So what is the induced EMF? So is going to be increases. If speed increases, induced EMF also increases. Okay, so next we can see the next problem. So a 4-pole lap wound DC generator has a useful flux of 0.07 Weber per pole. Calculate the generated EMF when it is rotated at a speed of 900 rpm with the help of prime mover. So armature consists of 440 number of conductors. So also calculate the generated EMF if the lap wound armature is replaced by wave wound armature. That is simply here they said. So initially it is a lap winding DC generator. So then after some time, the lap winding connection is removed and place the wave winding. What is the induced EMF? Okay, so simply write the given data here. So what is the given data? What is the given data? It is a 4-pole. That's why P equals to 4. And lap winding, number of parallel paths A equals to 4. And has useful flux per pole. That is what? 0.07 Webers. Okay. And calculate induced EMF. So that's why you can find the easy. That is equals to pi Z NP by 60 into A. So when it is rotated, speed is 900 rpm. What is the speed? 900 rpm. So on the help of prime mover. So armature consists of what? 440 number of conductors. So what is the Z? 440. Okay, that is equals to 462 volts. Okay, so that is 440 conductors. Simply use the formula E is equals to pi Z NP by 60 into A, that equals to 0.07 Webers into Z 440 N 900 P 4 by 60 into A equals to 4. So by calculating this, we are at 462 volts. Then next one, also calculate the generated EMF if lap wound armature is replaced by wave wound armature. So lap wound is replaced by wave wound. That means what? Change of number of parallel paths. So if wave wound, the parallel paths is going to be 2. So okay, so here the EMF equation as it is, and what are the given data? 0.07 flux into 440 conductors into 900 rpm, and poles are 4 by 60 into A equals to 2. Then what happened? 924 volts. Okay, so in this, what if any lap wound mission, they simply change the wave wound mission, means the induced EMF double than previous. Okay, so these are the problems on EMF equation. So here next we can see the representation of DC machine in any circuits. So it is a simple circuit connection of DC machine. So in the DC machine, DC generator, it is placed in the circle. Inside the circle we are placing a G. It is the generator. It acts as a armature. This is the armature. So this armature connects a prime mover, that is a PM. PM is nothing but prime mover. This prime mover is useful to provide the mechanical energy to the generator. Okay, so that's why, so each and every generator, they must have the prime mover. Why? Because it provides the mechanical energy to the generator, and this circle is shown the generator armature. So A1, A2 are the armature terminals, and F1, F2 are the field terminals. So F1, F2 are the field terminals, and the arrow indicates the direction of induced EMF. So direction of induced EMF. This is the representation of DC generator. Okay, so thank you for watching this video. Okay, this is the explanation of EMF equation and problems on EMF equation and how to represent the DC generator in